In 1952, a brilliant mathematician and rear admiral in the United States Navy created a revolutionary program that would transform how humans communicate with computers forever. Grace Hopper invented the first compiler, a tool that translates human-readable code into machine language, making COMPUTER programming accessible to millions who could never master binary code. Her invention became the foundation of every programming language used today, yet IBM dismissed her ideas as impossible and refused to hire her, exemplifying how corporate short-sightedness and gender discrimination blocked one of the most important innovations in computing history. Grace Brewster Murray was born in 1806 in New York City into a family that encouraged intellectual curiosity in both sons and daughters. Her grandfather was a rear admiral in the United States Navy, and her father was an insurance broker who believed strongly that his daughter deserved the same educational opportunities as his son. Grace demonstrated exceptional mathematical ability from childhood, taking apart alarm clocks to understand their mechanisms and solving complex puzzles. She attended Vassar College, graduating in 1928 with degrees in mathematics and physics at a time when fewer than 5% of college students were women. She continued to Yale University, earning a master's degree and doctorate in mathematics by 1934, becoming one of the few women in America with a PhD in her field. Grace taught mathematics at Vassar College throughout the 1930s, building a reputation as an exceptional educator who could explain complex concepts clearly. When World War II began, she attempted to enlist in the United States Navy but was initially rejected for being too old at 34 and too light at 105 pounds. She persisted, obtaining a waiver and joining the United States Naval Reserve in 1943, assigned to the Bureau of Ordnance Computation Project at Harvard University. There she encountered the Mark I computer, a massive electromechanical calculating machine that filled an entire room and made clicking sounds as it processed military calculations. This introduction to computing technology would define the rest of her life and revolutionize the field. The Mark I computer operated using machine code, sequences of zeros and ones that directly controlled the machine's electronic circuits. Programming the Mark I required writing instructions in binary notation, an extraordinarily tedious and error-prone process. A single mistake in thousands of binary digits could cause calculations to fail, and finding errors required checking every digit manually. Only mathematicians and engineers with specialized training could program these early computers, severely limiting who could use computing technology. Grace recognized immediately that this barrier would prevent computers from reaching their potential to transform science, business, and society. Grace became one of the first programmers of the Mark I, learning to write complex machine code instructions for BALLISTIC calculations and other military applications. She wrote the operations manual for the Mark I, a 574-page document that became the foundation for modern computer documentation. Her clarity in explaining computing concepts made her an invaluable resource for training other programmers during and after the war. She observed that many programming tasks were repetitive, with similar code sequences appearing in multiple programs. This observation sparked the insight that would lead to her most important invention. If you want to discover more revolutionary women whose groundbreaking inventions were dismissed by corporations and erased from technology history, subscribe now and activate the notification bell so you never miss these infuriating stories of genius rejected and contributions stolen. After World War II, Grace remained in computing research, joining the Eckert MAUCHLY Computer Corporation, which was developing the UNIVAC-1, one of the first commercial computers. She continued to see programmers writing the same machine code sequences repeatedly, wasting time on routine translation tasks. She conceived of a program that could automatically translate human-readable instructions into machine code, eliminating the need for programmers to work in binary notation. This idea was revolutionary because it proposed that computers could program themselves by translating higher-level instructions into the machine language they understood. Most computer scientists of that era believed this was impossible, arguing that only humans could write efficient machine code. In 1952, Grace Hopper created the first compiler, which she called the A0 system. The compiler read instructions written in mathematical notation, similar to how mathematicians naturally expressed calculations, and automatically generated the corresponding machine code. This invention meant that scientists and engineers could write programs using familiar mathematical language rather than learning obscure binary codes. The compiler checked for errors, optimized code efficiency, and produced machine language programs that ran as fast as hand-coded alternatives. Grace had created a tool that made computer programming accessible to anyone who understood mathematics, dramatically expanding who could use computing technology. The computer science establishment initially rejected Grace's compiler as impossible or impractical. Programming experts insisted that machine code written by humans would always be more efficient than code generated by automated systems. They argued that compilers would produce bloated, slow programs that wasted the limited memory and processing power of early computers. Some claimed that allowing non-specialists to write programs would result in unreliable software and system crashes. The resistance reflected both technical conservatism and professional gatekeeping by those who had mastered machine code programming and did not want their specialized skills devalued. Grace attempted to demonstrate her compiler to IBM, the dominant computer manufacturer of the 1950s. IBM executives dismissed her invention, telling her that computers could not understand English or mathematical notation. They insisted that machine code programming was the only viable approach and that her compiler was a theoretical curiosity without practical application. IBM refused to hire her or license her compiler technology, a decision that would cost them market leadership in software development. This rejection exemplified how corporate conservatism and dismissal of women's technical contributions led companies to miss transformative innovations. Despite institutional rejection, Grace persisted in developing compiler technology throughout the 1950s. She created the B0 compiler, which introduced the concept of subroutines, reusable code blocks that could be called from multiple programs. She developed the Flow-matic compiler, which used English language commands instead of mathematical notation, making programming even more accessible. Flow-matic allowed business users to write programs using phrases like ADD payroll to total, revolutionary for non-technical COMMERCIAL applications. Her work demonstrated that compilers could support multiple programming styles tailored to different user communities. In 1959, Grace participated in the conference that designed COBOL, the common business-oriented language that would become the most widely used programming language for decades. COBOL was built directly on the compiler technology Grace had pioneered, using English-like syntax that business programmers could understand. Grace's Flow-matic compiler became the basis for COBOL's design, though she received little credit for this foundational contribution. COBOL programs ran on UNIVAC computers initially, giving UNIVAC a temporary advantage over IBM in the commercial computing market. IBM eventually recognized its error and developed COBOL compilers, adopting the technology they had dismissed when Grace first proposed it. The impact of Grace Hopper's compiler invention on computer science cannot be overstated. Every modern programming language from Fortran to Python relies on compiler technology that translates human-readable code into machine instructions. Software development employs millions of programmers worldwide, a profession that would not exist without compilers making programming accessible. The software industry, worth trillions of dollars globally, is built entirely on the foundation Grace established with her first compiler in 1952. Without compilers, computing would have remained a specialized tool for a tiny elite rather than becoming the universal technology that transforms civilization. Grace continued her pioneering work in computer science while maintaining her naval career, eventually becoming a rear admiral. She promoted standardization in programming languages, arguing that portable software that could run on different computers was essential for commercial adoption. She advocated for human-readable programming languages long before the computer industry accepted this approach as standard practice. She trained generations of programmers and computer scientists, always emphasizing clarity, accessibility, and questioning conventional wisdom. Her motto, "IT is easier to ask forgiveness than permission," became famous in technology circles, encouraging innovation despite bureaucratic resistance. The famous story of finding an actual moth in the Mark II computer and coining the term bug for computer errors is often attributed to Grace, though the term predated her usage. What is accurate is that she popularized debugging as the term for finding and fixing programming errors, and she developed systematic debugging techniques still used today. Her practical approach to computer programming emphasized that errors were inevitable and that good programmers needed effective methods for finding and correcting mistakes. This attitude contrasted with the perfectionism of many early computer scientists who viewed programming errors as personal failures rather than normal aspects of software development. Grace Hopper remained in the United States Navy until 1986, retiring at age 79 as one of the oldest serving officers. She received numerous awards and honors late in her career, including the National Medal of Technology in 1991 and the Presidential Medal of Freedom in 2016, awarded posthumously. A United States Navy destroyer was named in her honor, the USS Hopper, commissioned in 1997. Google honored her with a Google Doodle on what would have been her 107th birthday in 2013. These recognitions came decades after her most important work, when her contributions could no longer be denied or minimized. The gender discrimination Grace Hopper faced throughout her career was constant, though often subtle. Male colleagues questioned her technical competence despite her doctorate in mathematics and proven programming expertise. Corporate executives like those at IBM dismissed her ideas partly because they came from a woman in a field dominated by men. She was frequently the only woman in technical meetings and computer science conferences, isolated by her gender in a profession that treated women as inherently less capable. Yet she persisted, using humor, competence, and determination to overcome barriers that stopped many other talented women from succeeding in technology. The contrast between Grace's compiler invention and IBM's rejection illustrates how corporate culture can blind companies to revolutionary innovations. IBM dominated computer manufacturing in the 1950s and had the resources to develop any technology they chose. They could have licensed Grace's compiler, hired her, and established software leadership that would have been worth billions. Instead, their technical conservatism and inability to recognize genius in a woman led them to dismiss the invention that would define the next 70 years of computing. Other companies that embraced compiler technology gained competitive advantages, while IBM had to play catch-up in software development. Modern software engineering owes everything to principles Grace Hopper established with her first compiler. The idea that programmers should write in high-level languages rather than machine code is now so fundamental that few people remember it was once controversial. Integrated development environments, code libraries, and automated testing all descend from her insight that computers should help programmers rather than requiring programmers to think like machines. The abstraction layers that make modern software development possible trace directly back to her compiler design. Grace Hopper's vision extended beyond technical innovation to include social transformation through computing accessibility. She believed that computer programming should be accessible to scientists, businesspeople, and anyone who needed computational tools. Her compilers democratized programming, breaking the monopoly of specialized machine code experts. This democratization enabled the explosion of software development that created the digital age. Without her insistence that programming should be accessible, computing might have remained a specialized tool rather than becoming universal. The educational impact of Grace's work transformed how computer science is taught. Students now learn to program using high-level languages with clear syntax and readable code, building gradually toward understanding machine-level operations. Programming education reaches millions of students worldwide, creating a workforce capable of building software systems. This would be impossible if students had to start by learning binary machine code as early programmers did. Grace's compilers made computer science education scalable and accessible. Grace Hopper passed away in 1992 at age 85, having witnessed computing transform from room-sized machines operated by a handful of specialists into personal computers in every home and office. She saw her compiler technology become the foundation of the software industry, though she never received the financial rewards that male tech entrepreneurs of later decades would accumulate. She died knowing that her inventions had changed the world, even if history had not yet given her full recognition. Her legacy lives in every line of code written in any programming language, in every software application running on billions of devices worldwide. Today, as programmers write software in Python, JavaScript, C++, or any other high-level language, they are using tools that descend directly from Grace Hopper's first compiler. Every software company, every technology startup, every computer science department exists because she made programming accessible to humans rather than requiring humans to communicate in machine language. The trillion-dollar software industry is built on foundations she laid in 1952 when she created the world's first compiler. Grace Hopper's hidden genius invented compiler technology that made computer programming accessible to millions and created the modern software industry. Yet IBM dismissed her revolutionary invention as impossible, corporations refused to hire her, and her contributions were minimized for decades because she was a woman in a male-dominated field. Her story reveals how gender discrimination and corporate short-sightedness blocked one of the most important innovations in computing history, and how one woman's persistence despite constant rejection changed the world anyway.